Ladies and gentlemen, this is a question before us, Waec 2024. One of the questions under equilibrium of forces. The question reads, a uniform stick AB of length L and mass M is balanced horizontally on a knife edge 10 centimeters from A. When an object of mass 400 grams is suspended at A, when the knife edge is moved 5 centimeters further, the object has to be moved to a point 9.00 centimeters from A for the stick to balance. The question is, represent the balance system with a suitable diagram. Number 2, determine the A, mass M of the stick, and B, the length L of the stick. Ladies and gentlemen, from this question, you understand that we're going to have two separate diagrams. The first, we're going to represent the stick AB with total length L, uppercase, and then the center of gravity will become L over 2 to the left and L over 2 to the right, so that we can obtain equilibrium based on length. Now, the knife edge is balanced at 10 centimeters from A. So you can see a knife edge being placed at 10 centimeters from A. Then the mass of 400 grams is suspended at A, which is meant to be the point of origin, 0. Hence, you can see 400 grams of mass suspended at A. Then we're going to have another diagram because the knife edge is moved 5 centimeters further. Hence, the knife edge will now be placed at 10 centimeters plus 5, which will give you 15 centimeters from A. The object has to be moved to a point 9.0 centimeters, meaning the 400 gram mass is now moved to 9 centimeters from A, which is 0 centimeters, so that the stick can balance. So we are asked to represent the balance system with a suitable diagrams. So we're having two diagrams here. Look at it. Now for the first diagram, you will see that our center of gravity, that's where the other mass is placed, M. Now the distance between the knife edge and the mass M2 will now equal L over 2 minus 10. Take note of that, so that we can have L over 2 minus 15 for the second diagram, which is when the object was moved further away from the point of origin. Hence, depicting this into the moment of force that states that the algebraic sum of the moments of all the forces about any axis perpendicular to the plane of the forces must be 0. In other words, we can say that the sum of the clockwise moments about any such axis must equal the sum of the anti-clockwise moment about the same axis. Hence, what are the triune components from this question? We'll see number 1, we have the masses M1 and M2. M1 is 400 grams, M2 is unknown. Then distance is the length. We have x1 for M1 and x2 for M2. Then we have forces which can be downward weight or upward reaction. So from the principle of moment, we know that summation CW, which is clockwise moment, is equal to summation ACW, which is anti-clockwise moment. So from the first diagram, taking the moment about the pivot, which is the knife edge, please, your concentration must be at the positions of the two masses towards the pivot, which is the knife edge. The other part is useless to you when it comes to the calculations under equilibrium of forces. The only usefulness of the other part is in subtraction. You can see that in the second diagram, where we're going to cut off the 9 centimeters by subtracting 9 from 15, which gives you 6 centimeters, and then the other part is cut off. So your concentration must be where the two masses are hinged towards the pivot, which is the knife edge. Hence, we know that the moment of force about the clockwise moment must equal that of anti-clockwise moment, which will now become force multiplied by distance, and is equal to force multiplied by distance on both the right hand side and the left hand side. So mathematically, now becomes M1 x1 m1 is equal to m2 x2. By substitution, we know that our m1 is 400 multiplied by x1, which is 10, is equal to m, which is m2 now, into L over 2 minus 10. But we can divide through by m, so that 4,000, 10 multiplied by 400 is 4,000, divided by m will equal m into L over 2 negative 10 over m. I hope you get this. So that 4,000 over m will now equal L over 2 minus 10. M will cancel m. Multiply through by 2, so that we can make L the subject of the formula. Then we have 4,000 multiplied by 2 divided by m is equal to 2L over 2 negative 2 into 10. So that 8,000 divided by m is equal to L negative 20. So that if you collect like times, L is equal to 8,000 over m plus 20. We have equation 1. Now from the second diagram, you will see if we take the moment of force about the pivot, summation CW is equal to summation ACW. So that force multiplied by distance is equal to force multiplied by distance. Hence, m1 x1 is equal to m2 x2. Our m1 is 400 into x1 will become 15 negative 9 is equal to m into L over 2 negative 15. So that 15 negative 9 will give you 6, and then you have 400 multiplied by 6 is equal to m into L over 2 negative 15. Now we can divide through by m, so that 2,400 divided by m is equal to m, so that 2,400 over m is equal to m into L over 2 negative 15 divided by m. M will cancel m. Hence we have 2,400 divided by m is equal to 1 over 2 negative L over 2 negative 15. Now if we multiply through by 2, we can have 2,400 multiplied by 2 divided by m, which will equal 2L over 2 negative 2 into 15. So that we'll be left with 4,800 divided by m is equal to L negative 30. Then if you make L the subject of the formula, L is equal to 4,800 divided by m plus 30. Equation 1, equation 2 gotten. But recall that L is equal to L. We can equate the two L to each other, so that we have 8,000 divided by m plus 20 is equal to 4,800 divided by m plus 30. Collecting like terms, 8,000 over m negative 4,800 divided by m is equal to 30 negative 20. So that 3,200 divided by m is equal to 10. Cross multiplying, we have 3,200 is equal to 10m. Divide through by 10, so that m will now equal 3,200 divided by 10, and that will give you 320 grams. So the m, which is unknown, the m2 is 320 grams. Now we need to find our L, which is B. Now for us to find L, we can substitute m is equal to 320 in either equation 1 or 2. We are going to verify that. From equation 1, L is equal to 8,000 divided by m plus 20. So that L is equal to 8,000 divided by 320 plus 20. So that L is equal to 8,000 divided by 320 will give you 25 plus 20, which will give you 45 centimeters. Or let's try equation 2. L is equal to 4,800 divided by m plus 30. But 4,800 divided by 320 plus 30 is equal to L. Hence 4,800 divided by 320 will give you 15 plus 30 is equal to 45. So from this we can see that we have been able to verify the moment of force, and by solving the problem presented. If you have further questions, you can drop them in the comment section, and if you like this video, you can share with your friends so they can benefit from this. Connect to our social media handles at Physics Bible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped. Stay liquid.